If you want partial credit, if you have no idea what's going on and you still want some points, make sure that your givens show up in your drawing. So AD parallel to CB. Make sure it shows up here. We don't have to really give a reason, but we do. We write down given. If it's there, it should also be up here. How do we show that parallel is parallel in our figure? Just put a bunch of arrows on there. Make sure it's the same amount. It'd be 1 and 1, 2 and 2. AD and BC. Then we got another one here, so I'm going to put that in. AD congruent to CB. That's given. It's got to show up in here. How do we show congruency? Slash marks. I'm going to put 3, and I'll put 3. Put whatever I want. You know that this is the triangle congruency chapter. So you know that you're going to probably use this on every single proof. Whether it's the actual proof statement, or if it's something that goes beyond that. So no matter what, try to prove that the triangles are congruent. In this case, that's going to be our last line. Start thinking of your big 3: vertical angles, common side, parallel lines. Do we have a common side? Put a mark on it. If you put a mark on a common side, make sure that the statement shows up in your proof. How do we show common sides here? Yeah. Say segment AC instead of line. We say the common side is equal to itself or congruent to itself, but we don't use the term common side. What do we use? Reflexive property. Every year, people will put the common side in the drawing, but they won't put it into their proof. Actually move it to here. That's good, but that's not enough to use one of these 5 over here. I need some more information. Once you have parallel lines, darken them in. Darken in your parallel lines and then complete the Z shape. What angles are caught by that Z? 3 and 2. Not the 1 and the 4, the 3 and the 2. That's what I need to write down. 3 congruent to 2. And someone in my other class asked if he could use symbols to show the if-then statement. And that's fine. What's the symbol for an if-then statement? Little arrow. So instead of writing out an if-then statement, he decided to say this: lines, parallel, arrow, alt, int, angles, congruence. If you want to write in if lines parallel, then alt, int, angles, congruent, that's fine. But if you want to use the arrow, that's fine. Okay, that's all right also. But I need to see a conditional. I need to see a hypothesis leading to a conclusion. You can't write that unless lines are parallel. Did we say that the lines were parallel? Mm-hmm. Up here. So I'm okay. The top of the Z and the bottom of the Z were shown to be parallel earlier on. Is that enough information to say that the triangles are congruent? Triangle ADC congruent to triangle CBA. And what did we say this was? Underline each one of those. And make sure that it's actually in the drawing. Let's put an S here. We've got an angle here. And we've got a side here. Focus on one triangle. Some of you are labeling everything that's in the drawing. You want to label one triangle. You had an S there, you had an angle there, you had an S there. How many letters in SAS?
3.
3. So, you should have 3 congruency statements that you've written down previous. Do we have 3 congruency statements previous? 1, 2, 3. If you can't count 3 congruency statements, then you forgot to put something down. That's how you check.
When do we use the CPCTC?
That'll be on the other page.
Okay.
On this page, look at all the proofs. Every proof on this page stops with the triangles being congruent. If you go beyond that, that's when you start using CPCTC.
Oh, okay.
These are the type of questions you need to ask today and not the day of the test. Number 2. Let's throw our givens up here. S, J, what does that symbol mean? Perpendicular. I got given. What should I be putting into the drawing? I'm supposed to put all the givens in the drawing. How do I show that?
Right angles.
Up here. Put some right angles there. Just doing that's going to get you partial credit. Anytime midpoint or bisector shows up, underline it and circle what follows. If you circle what follows, then you're actually telling yourself what gets cut in half. The HW gets cut in half. Put some slash marks to show that it got cut in half. So anytime midpoint or bisector shows up, something needs to go into the drawing to show the 2 equal pieces that were created by the cutting in half. That needs to go down here. J is midpoint HW. You can shorten it up a little bit if you want. That's a given. I have to put that information into my proof. So look at the slash marks. That was HJ congruent to WJ. If you put them in the drawing, they got to show up here. What do you think your reason is? Kelvin? Why did we put those slash marks in there? Midpoint. You look at the word that you underlined. Definition of midpoint. Because you know the definition of midpoint, you wrote down that those 2 pieces were equal. Don't overthink this. There's a reason why these terms are being given to you, so that they'll eventually show up in your proof. I haven't really put this in yet. If those are 90 degrees, aren't they equal? Let's write it down. Other teachers, other textbooks, other courses would have you put in a couple of steps for this. This is all I need. You put boxes there. We're saying that they're equal. Why did we put the boxes in there? Yeah. Now, some teachers and books would say, no, you need more than that. That's fine for me. Another textbook, another teacher might say, you got to write down that 1 is a right angle and 2 is a right angle because of definition of perpendicular. And then you have to have another line saying that they're congruent, definition of right angles. I don't need that. This is fine. What's left? What can we put in there from this stuff? Yes? We got a common side. Use a different amount of slash marks whenever you're looking at congruency. Don't put just 1 on there. We want to keep that separate from this stuff up here. How did we put the common side from this one into this. How are we going to do that over here? How do you show common sides in your proof? You said the how. All right, you do reflexive property. We know that's the technical term. But how does it show up in our statements?
We do the same letters on the left and the right side.
JS is that common side. We're just saying that it's equal to itself. It's in both triangles. We're just not separating the two triangles. Is that enough to actually do the proof statement? Triangle SHJ congruent to triangle SWJ. Look at one triangle, tell me the components that you see that match up with one of these five. Calvin? SAS. I see a side, I see an angle, and I see a side. But double check, how many letters are in SAS? So you should have 3 congruency statements previous to that. Do we have 3 congruent symbols? 1, 2, 3. Are 2 of those dealing with sides? These 2. And is one of them dealing with angles? Okay. So we're probably okay.
Oh.
If you didn't have 3 there, then you don't have enough information. You probably forgot something. Maybe it was the midpoint line. Maybe it was the angle line. Number 3, we have parallel lines. So let's put in some parallel symbols, some arrows. The mistakes we're seeing on other tests, people are confusing the arrows with congruency markings. This doesn't mean that they're necessarily equal yet. We're just saying that they're in the same direction. O is the midpoint of what? Do that. Underline and circle. Whatever you've circled after the word midpoint is the thing that's getting cut in half. So F to H is what we're breaking into 2 pieces. How do you show that it's broken into 2 pieces? What should I throw in here? Am I breaking up the other segment? No, I have no information about EG. All I'm dealing with is FH. And it looks like those are the only 2 givens at this point. Make sure that they show up here. A lot of people are just jumping into the proof in other classes. They're not writing down their givens. You need the givens because this is like a recipe. You're showing somebody how to bake a cake. You want a good cake. O is midpoint of FH given. That right there would give you half credit. You got the stuff in the drawing, you got the stuff in the proof. What are we trying to do? We're trying to prove triangles congruent. Tell me how you would start, or what did you do if you did this problem? Kelvin?
So I wrote FO instead of HO because it's the definition.
You put slash marks in the drawing, but we didn't really put anything down here. So we need to write FO congruent to HO. And what would be your,
Definition of midpoint.
since we're talking about midpoint, definition of midpoint. We're writing down something and then we're saying why we wrote it. That's good, but that's not enough to get me one of those 5. What else can I put in there?
Vertical angles.
How about vertical angles right here and here? Angle 3, congruent to angle 4. And you already gave me the justification, vertical angle theorem. That's still not enough. If I look at just one triangle, that's only 2 pieces of information. I got an angle and a side.
Parallel lines of interior.
What I decided to do was look at 1 and 5. Did anybody else look at 1 and 5?
I did.
That's what I did. It's not the only answer. You could have gone towards 2 and 6. What I thought about was alternate interior angles, because 90% of the time when parallel lines show up, you probably got some Z shapes running through your diagram. But notice I've written down the other pairings. You might see corresponding. You might see alternate exterior. You might see same side interior. Not as much, but you could see that. If lines parallel, then alt, int, angles, congruence. You can either write it that way as an if-then statement, or you can write it like we did up here with an arrow in between. Either one's okay. Look at my markings and focus on just one triangle. What do I have? Angle, side angle. And all I'm trying to prove for this one is 2 triangles again. Triangle, EFO, congruent triangle, GHO. In your own words, what does this mean?
Triangles are congruent.
In your own words, what's another word for congruent? They're exactly the same, they're identical. How many parts are there within one triangle? 6. You got 3 sides, you got 3 angles. But we never usually have 6 parts. How many parts do we have here? We know 3 of those parts are the same as 3 other parts in another triangle. That's enough information to say that they're identical. Do we have 3 congruencies previous?
Yes.
1, 2, 3. So we're probably okay. If you don't have 3 previous, then something's missing. And
Does it matter if it's AS or AAS?
where, according to my markings, where is this side? Is it directly in between the 2 angles? Is it between this one and this one? Yes. That's why I'm doing the one with the S directly in between. If you do 2 and 6, and had done that on the line where I have 1 and 5, then it would be AAS, because that side wouldn't be between 2 and 3. So it all depends on which ones you choose. I could have chosen 2 and 6, but I just didn't. Did anybody use 2 and 6? Did you use AAS? Everybody's proof is going to be a little bit different. This is why this test takes me forever to grade. So I got to look at every single line.
No, I'm laughing at, why would you say that? What is that?
Pipes, steam, heating. What did I circle? Parallel. How do you show that? You put a couple arrows in. Put that in. What do we normally think about for parallel lines? But not in this case. Now we have to actually look at one of these other 3. So it doesn't mean that it's always alternate interior. In this case it's not, and I'll show you why. LM parallel KA given, and K is midpoint LC. If it's the midpoint, put some slash marks to show that you have 2 equal pieces. We have 3 givens this time. We got 2 and 5. 2 and 5. That would get you half credit. You've shown all the givens in the drawing. You've shown it in your proof.
That noise feeling you make. I'll just go look at our pencils. Did you find out?
Mine is sharpening so many pencils.
That's all I need to know.
If it's 100%, they'll get automatic.
Can we like go over there and tell them, ask them to stop?
If it's missing.
What else should I be putting right here that I have not yet?
Definition midpoint.
All right, definition of midpoint, good. I didn't actually show this. I gotta put in that LK is congruent to KC. This segment is the same as this segment. This is what people are getting wrong. They're putting things in the drawing, they're not putting them into their proof.
Would it be CK or KC?
I'm not too concerned with that,
Okay.
with that correspondence. And actually, in this case, it would be LK and KC.
Okay.
That's the correct correspondence. We're getting closer. I have two pieces. I've got this, and I've got the angle. I got a side and an angle. Let's focus on 1 and 4. That's what I chose to look at. That's not alternate interiors. Which one of these other ones is 1 and 4? Corresponding. So this is a case where I still say if lines parallel, but now I'm saying corresponding angles congruent. So parallel lines are showing up. You got to think of everything you learned back in chapter 3 dealing with these different angle pairs. Is that enough to say that the triangle LNK is congruent to the triangle KAC, which is what we're trying to prove? What? AAS. If I focus on just that triangle, I got an angle, I got an angle, I got a side. The side is not directly in between. So that's why we're saying AAS. How many letters in AAS? 3. So you should have 3 congruency statements previous. Do I? I see 1, I see 2, 3. So I'm probably okay. Notice all 4 of these ended with triangles being congruent. These are the shorter ones. You'll see a couple of these on your test. What do I need? I need page 2.
Are you okay?
That's what I need to see for the givens. Show me that that's equal to that. Underline, bisect, circle OPR, because that's what's getting cut in half. This time it's not a side, it's not a segment, it's an angle. If you cut an angle in half, what do you end up with?
A line.
2 equal.
Angles. I mean lines. Line. Angles. Lines.
If we're cutting an angle in half, you should have 2 equal angles. Where is OPR? Left side or right side?
Right side.
So what 2 angles must then therefore be equal? 3 and 5. Put an arc there, put an arc there. If you cut an angle in half, you should end up with two equal angles. If you,
What's the second line of the thing? It's in that bisection.
yep, I put this right here. I just shortened up bisect.
Oh,
You have to put that in the drawing. You actually have to now say that 3 is equal to 5. And why did we say they were equal? Definition of bisect. I don't care what you write there in the form of the word. It could be angle bisector. It could be, that's fine.
oh, I thought it was someone.
So it could be definition of angle bisector, definition of bisector, definition of bisect. I don't care. As long as you're writing down something to do with bisect so that I know you understand that you wrote 3 is equal to 5 because this is telling you the angle got cut in half. What else can I add to this drawing from my big 3?
Oh, on the side.
Put some slash marks. Then write down the side is SP, congruent to SP. What's my official reason for something like that? Reflexive property. You notice I haven't even looked at what I'm trying to prove. This is chapter 4, so I know I'm probably going to prove the triangle's congruent. So I haven't even looked at this yet. It doesn't mention triangles in there, but I know that's where I'm headed. Is that enough to prove that it's congruent? What do we have? We have a side, an angle, and a side. So now triangle SOP is congruent to triangle SRP. And you said SAS? Are there 3 congruency statements previous? 1, 2, 3. So I'm probably okay. Yes. This right here? So I have to keep going. What did I just accomplish saying that? Yes.
That the triangles correspond to each other and makes the big.
Right. They're identical. That's what I've proven so far, that the top one is identical to the bottom. If they're identical, shouldn't all their little pieces be identical?
Yeah.
Isn't OS and RS parts of those triangles? So I can now write the prove statement, which is OS congruent to RS. And what was my little abbreviation instead of writing a big long explanation? Instead of saying, since the 2 big triangles are exactly the same, all their little components are the same, you write CPCTC. If you want to write out that whole big sentence, you'll get credit for it, but there's no need for it. What's an alternative that might show up on an SOL test besides CPCTC? What else did we write? Definition. Definition of congruent triangles. You can't write CPCTC unless you've already said that the triangles are congruent. So I don't want to see CPCTC showing up early in your proofs. They're normally near the end.
What's the point of writing it? Like, why do I write it like you're pointing out?
Which one? It takes the place of saying, since the 2 triangles have been proven to be exactly the same, all of their little corresponding pieces are exactly the same. We just say CPCTC. Corresponding parts of congruent triangles are congruent. We're going to write some arrows down. This next one is an easy proof because isn't it almost the same information? Isn't this the same as this? So I'm not going to rewrite things. I'm just going to do this. All of that's the same. So put arrows for the first 5. 1, 2, 3, 4, 5. It's going to be exactly the same. And what you can do is, let's put that last line, triangle SOP congruent to triangle SRP down, just to show that we're going to do the same exact first 5 steps. We're going to prove that the triangles are congruent. What normally comes after that? Some sort of CPCTC, but I have a different prove this time. What are we trying to prove? What angle? Which side is OSR on, left or right? Left. So if I want that to be bisected, what angles would have to be the same?
1 and 6.
1 and 6. Have we mentioned 1 and 6 anywhere?
No.
That's probably what we have to mention. We have to talk about those two. So that's going to be the next step. Is 1 in the top triangle? Is 6 in the bottom triangle? Do they correspond? They're in the same spot. They correspond. It's CPCTC. It doesn't matter whether it's segments or angles. If they're in the 2 triangles and you just proved that the triangles are identical, they must be identical. Well, if those 2 are equal, doesn't that mean that SP cut it in half? Now you can write your proof statement. SP bisects angle OSR. What do you think your justification is? How do you know that this is occurring?
I knew it.
Can I please go there and tell me stop recording if someone have a completely unsharpened pencil, so I can just go over there and stop recording.
That's not. Are you serious that you think that that's sharpening pencils? That's steam running through pipes.
I can't do it. It's killing me. It honestly makes me
If you want heat in the building, then occasionally, that usually happens the first couple times.
It's honestly driving me crazy. Are you sure? Is it like that out in the hallway? Can I just sit in the hallway?
You're putting arrows and slash marks on the same exact pair of sides, WX and YZ. You know, I'm hearing some sounds that are irritating me right now. So let's focus. You know this is chapter 4. You know that we've been proving triangles congruent. So just prove the triangles congruent. And then we'll see where we go from there. What else do I need? There is a common side. So WY congruent to WY. And that's reflexive property. That's good. We've got parallel in there, and I see some Z shapes. But be careful. Which sides are parallel? Top and bottom or left, right? So darken those in. Complete your Z shape. What's caught by that Z?
No, 3.
3 and 2. So those are the only ones that I can mention down here right now. 2 and 3. if lines parallel, then alt int congruent. Is that enough? I see slash marks here, I see an arc here, I see a slash mark there. What do I have within my triangle? What's going to allow me to say that XWY is congruent to triangle ZY? Side angle side. And that's because I got a side, I got an angle, and I got a side. Make sure you're focused on only one triangle at a time. You had slash marks here, you had a slash mark for the common side, and you had an arc in between for the angle.
How many pieces are on the test? Do you know?
There'll be 4 proofs. So you can probably expect 2 of them will be like the ones on the front of this paper. 2 of them will be like what you're seeing here. And then 1 will be like the coordinate proof that we're going to do in about 5 minutes. How many people can graph points? If you can graph points and do the distance formula, then the 5th proof will be easy. That's great, but that's not what we're trying to prove. What angles have we not used yet?
1 and 4.
1 and 4. So how about if we use them? We only have a limited amount of things that we can do. So let's say that 1 is equal to 2. What have we been using as our justification after proving the triangle is congruent? You know that that's what you're going to do right after proving the triangle is congruent. That still doesn't get me what I want. I'm saying that that's equal to that, but look what I'm trying to prove. I'm trying to prove that XY parallel ZW. Now you got to think back to your last test.
Which angle 1 is congruent to angle 2?
I'm sorry, angle 4. I circled 4 and I wrote 2. Thank you. X1 parallel ZW. Very good catch. What did you do last test when you were proving that something was parallel? What kind of justification? Numbers. Which one of those applies to angles 1 and 4? Good. Alternate interior angles converse. Anytime you're proving that, it's got to be one of those converse titles. If you think of the main idea of the chapter is proving triangles congruent, that'll help you get through the first chunk. If that's what we're proving, you're done. If it goes beyond that, you know that the first line after that is probably going to be a CP/CTC line. In some cases, you stop there, like in number 5. In number 5, we stopped at CP/CTC. But sometimes you go a little bit further. These are the only ones we've been studying. This is it. It's not going to look any different than this. I'm not going to worry about number 8 because that's showing a similar situation with proving. That's enough for those proofs.